This is section B1, so Appendix B, Section 1, Sequences, Series, and Summation Notation. This first video will be about sequences. Here's two examples of sequences. We all know what a sequence is, some kind of pattern. Here we're using numbers to help us define our pattern. So the first sequence I have listed here, 1, 2, 3, 4, 5, 6, 7, etc. That dot, dot, dot just means it keeps going, following that same pattern. So this one we're going 1, 2, 3, 4, we're adding 1, going from one term to the next. So the next sequence there, 10, 50, 25, 12.5, dot, dot, dot. So in that one, we're dividing by 2 each time, 10, 50, 25, and then the dot, dot, dot just means it can keep going forever. So the terms of a sequence, we call the terms just the individual parts. So the first term in this sequence is 1, the second term is 2, the third term is 3, the fourth term is 4, the fifth term is 5, etc. Just which term is it? So the first term is the very first part of the sequence. Second term, the next part of the sequence. So to write this, just our notation, we usually use a lowercase letter. This case we're using A. So A sub 1 is what that first one is. That means the first term. A sub 1 means the first term. So our first term is 1. A sub 2, that's our second term. Our second term is 2. A sub 3 is our third term, and our third term is 3. And we could keep following that same pattern. So A sub 10, the 10th term, of course, would be 10, because we're just adding 1 each time. So what is A sub n, or the nth term? So that one, we could just look at our pattern. A sub 1 was 1, A sub 2 was 2. So it looks like our index, that 1, is the same thing as how we could just define the sequence. So if we wanted to find the 50th term, we'd just say, okay, what is the 50th term? Would have to be 50. We could also write that as this right here with the curly brackets. So we could say A sub n equals n. The curly brackets help us know that we're defining a sequence here. Okay, so let's find the first 4 terms of the sequence. Here we have a sequence definition. A sub n equals n minus 1 over n. So let's write the first 4 terms. So to do this, the first term, A sub 1, we're just going to plug 1 in for n in our sequence definition. So we have 1 minus 1 over 1. We just put in 1 for n. 1 minus 1 is 0, and 0 over 1 is, of course, 0. So our first term is 0. How about our second term? So we plug in 2 for n. So we get 2 minus 1 over 2. And 2 minus 1 is 1. So we have 1/2. So our second term is 1/2. To find our third term, we're just going to plug in 3 for n. So we have 3 minus 1 over 3. 3 minus 1 is 2, so our third term, A sub 3, is 2/3. And then A sub 4, plug in 4 for n. So 4 minus 1 over 4, which is 3 over 4. So our fourth term, or A sub 4, is 3/4. So in this way, we could find any term we wanted to. If I asked you to find the 15th term, you could say, okay, well, I can do that. I know about how to define the sequence. Each term of the sequence is defined by n minus 1 over n. So the 15th term would be 15 minus 1 over 15, which is 14 over 15. So we could actually find any term we needed to in this particular sequence. Let's do the same thing with this one. So here we're using a b to define it, b sub n, because we already used a. That's really why we're using b now. So let's do the same thing. So if we plug in 1 to find the first term, we have negative 1 to the nth power, so negative 1 to the first power, times 1 plus 1. So negative 1 to the first power is negative 1, and 1 plus 1 is 2. And negative 1 times 2 is negative 2. So our first term is negative 2. How about our second term, b sub 2? So plug in 2 for n. So we have negative 1 to the second power times 2 plus 1 is, so negative 1 to the second power is positive 1, and 2 plus 1 is 3, and 1 times 3 is 3. So we're just plugging in the term number for n and then simplifying as far as we can. So let's find 2 more terms. B sub 3, the third term, negative 1 to the third power times 3 plus 1. Negative 1 to the third power, negative 1 to any odd power is negative 1, and 3 plus 1 is 4. So we have negative 4. One more, b sub 4, would be negative 1 to the fourth power times 4 plus 1. Negative 1 to an even power is positive 1, and 4 plus 1 is 5. So we have 5. Now if we look at this, our sequence here, we have negative 2, 3, negative 4, 5, etc. We could just keep following the same pattern. So we're alternating between negative and positive. So we have negative, positive, negative, positive. Well, why does it do that? So if we need to alternate between negative and positive, that comes from this part right here, the negative 1 to the nth power. Because negative 1 to an odd power is negative, and negative 1 to an even power is positive. So that's how that's helpful then if we need to define a sequence that alternates between positive and negative. Okay, one more example like this. Let's write the first 4 terms of this sequence C. So C sub 1, now we're just going to plug in 1 for n. So C sub n is n squared over 2 to the n. So C sub 1 is 1 squared over 2 to the first power, which is just 1 over 2, or 1/2. C sub 2 is 2 squared over 2 to the nth power, so 2 to the second power. And 2 squared over 2 squared is just 1. C sub 3, or the third term, would be 3 squared over 2 to the third. So 3 squared is 9, and 2 to the third is 8. So 9/8. And if you could simplify the fraction, of course you would. Simplify as far as you can. So let's find one more, C to the fourth, or C sub 4. So we have 4 to the second power over 2 to the fourth power. 4 to the second power is 16, and 2 to the fourth power is 16. And 16 over 16 is 1. And then we could keep going. If you wanted the 9th power, you'd plug in 9, whatever power you needed. Okay, now what if we have a sequence and we need to write down the definition? So, for example, if we have this right here, we want to know the definition. What's the nth term of the sequence? So we have 4, 7, 10, 13, and we need to follow the same pattern. So what's happening? Well, our first term is 4, and then we're adding 3 each time. If we look, we add 3 to go from one term to the next. 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13. Well, that's kind of like a linear function. We're adding the same thing each time. So that means that what we're adding each time is like our slope. So we know we can start with 3n because we're adding 3 each time. But what are we starting with? We're starting with 4. So let's think about this. If a sub 1, we want it to be something. We want it to be 3. So a sub 1, we want to be 3 times 1. We want to plug in 1 for n, plus something, and it has to equal 4. So 3 times 1 is 3, and 3 plus what is 4? 3 plus 1 is 4. So how about if we wrote a sub n is 3n plus 1? Would that work for all of them? That worked for the first term, so 3 times 1 plus 1 is 4. Let's make sure it works for the rest of them. So how about the second term? For the second term, now we know we need it to be 7. So let's plug in 2 for n and see if we get 7. So we have 3 times 2 plus 1, which is 6 plus 1, which is 7. Let's make sure it works for the fourth term. You should just make sure it works for all of them. So 3 times 4 plus 1, which is 12, plus 1 is 13. Is that what our fourth term is? It sure is. It's 13. Looks like this is going to work. So here's our definition. A sub n equals 3n plus 1. Okay, let's define one more. So we have 1, negative 2, 3, negative 4, 5. So here we have an alternating sequence again. So let's start with that. So we have our first term is positive, our second term is negative, and then 1, 2, 3, 4, 5. Well, 1, 2, 3, 4, 5, we did that part, and that was just an n. So we need negative 1 to some power to make this work. So our first one needs to be positive. Our first term is positive 1. If I do negative 1 to the first power, we have a negative. So, and we need our first term to be positive. So what do? Well, here's what you can do. Take the negative 1 to the n minus 1 power. So now if we plug in 1, we get negative 1 to the 1 minus 1, which is negative 1 to the 0, which is positive 1. If we plugged in 2, we'd get negative 1 to the 2 minus 1, which is negative 1 to the first power, which is negative 1. And we do want our second term to be negative. So let's try that. So let's do negative 1 to the n minus 1. And then that's going to help us alternate between positive and negative. And then the 1, 2, 3, 4, 5, that's just the n part. So negative 1 to the n minus 1 times n. There's our sequence definition. Now let's make sure it works. So let's plug in 3 for n for our third term. So negative 1 to the 3 minus 1 times 3. Negative 1 to the 3 minus 1 is negative 1 squared, which is 1. And 1 times 3 is 3. So that one worked. Let's try the fifth term. For the fifth term, or let's try the fourth term. For the fourth term, we should get negative 4. So negative 1 to the 4 minus 1 times 4. Just plugged in 4 for n. Negative 1 to the third power, 4 minus 1 is 3, is negative. So we get negative 4. That's what we wanted for our fourth term, was negative. So just check and make sure your definition works. And if it does, then good, we've got it. So here's our sequence definition for the sequence 1, negative 2, 3, negative 4, 5. We're going to use this right here, negative 1 to the n minus 1 power times n. So if we need to alternate between positive and negative, we need to do a negative 1, and then you can do to the nth power or the n minus 1 power, whatever's going to help you get the negative and positive on the right term. Okay, so that's it for this video. The next video will be about series.